In this series of videos, we are going to be talking about the idea of conic sections. And in the first video, we're just going to quickly introduce what conic sections even are. So I'm going to start by just describing the big idea in words, and then I will show you a picture. So the big idea behind conic sections is that you have a cone intersected by a plane. So I'm going to put a little asterisk on top of the word cone because I want to make sure that we take a second to get on the same page about what we mean. So when we say the word cone, what we mean mostly is that we have a single right circular cone. Okay, so what is a right circular cone? It's probably what you all imagine when you think of a cone. So it doesn't lean to one side, and its base is a circle. In one of our conic sections, we're actually not looking at a single right circular cone, we're looking at a double cone, which is two right circular cones stacked on top of one another. So something that looks like this, roughly. So this is not perfect, but it's good enough. So there is a double cone, okay? So again, for conic sections, we are taking these cones and we're intersecting them by a plane. And so here is the picture that I would like to show you. So let me blow this up a little bit. And so here we have our 4 conic sections. So I'm going to go through them one by one. So in the first one, you are taking a single cone. So you'll notice that in this picture, all of the pictures show a double cone, but in all but one of them, we're only intersecting one of the cones. So here you can see that you are taking a flat plane and you're cutting the cone with it. So imagine yourself, I'm only going to draw pictures for a few of these, but imagine yourself taking this. You're taking your cone, there's your cone, and then you're taking your plane like so. So it's a flat plane. And then what you're doing is you're noticing what is the shape of the cut. Okay, so it's almost as though you are taking this cone and breaking it along where the plane cut it. So you'll see that you have the little top of the cone, right? And then you have sort of the rest of the cone. It's actually called the frustrum, which is a piece of a cone that doesn't have a top. Okay, and so what you're noticing is that this piece here and this piece here is a circle. Okay, so a circle is one of the conic sections. If we do the same thing, but rather than cut with a flat plane all the way through, instead we cut with a plane at a slant, like so. So you'll notice here that this plane, it doesn't go all the way through, right? It kind of cuts at the bottom. It cuts a bottom corner off of the cone. And so what you're left with, if you were to separate the two pieces of the cone, is you're left with a cut in the shape of a parabola. Now, you might be thinking to yourself, wait a minute, we had a whole section on parabolas earlier. And you would be right, except that in our unit on parabolas, we were talking about them in the context of quadratic functions. So when you have quadratic functions, right, we draw them like so. So we have f of x equals ax squared plus bx plus c. And no matter what, You know, the parabola can be opening up or opening down. It can be shifted, but it has a vertical axis of symmetry. So the line going through its vertex is vertical. Whereas in the land of conic sections, we're saying, hey, why can't a parabola open sideways? Or why can't a parabola even open at an angle, something like this, right? And so what you'll notice is that with talking about conic sections, we are very much talking about curves, and we have sort of moved out of the realm of functions. We're kind of in a pure geometric place where we're talking about curves that are not necessarily functions at all. By that same token, circles aren't functions either. Okay, moving on. So the next example of a conic section is an ellipse. So an ellipse and a parabola sort of come about in very similar ways, but you actually allow the plane that's going at a slant to go all the way through the cone. So you see that once again you're cutting your cone with a slanted plane, but this time it goes all the way through. And so it's kind of a cross between what you did with the circle and what you did with the parabola. And what you end up with is what some of you will think of as an oval, but it is called an ellipse. So a shape like this, kind of a smushed circle, is called an ellipse. And last but not least, our last conic section is the one where we're actually not ignoring the top cone. You remember in the first three conic sections, we're only looking at really one of the cones. But in the fourth conic section, we're looking at both. And we're taking the double cone and we're slicing it with a vertical plane. And what you can see is that when we do that, we end up with this two-lobe figure. We end up with two pieces getting cut off, the little piece here, like so, and the little piece here, right? And the cut side actually has two lobes. So a hyperbola looks like this, or if you were to you can also orient it the other way. So if you can imagine your cones lying down, your hyperbola might also look the other way. So we'll talk more about that later. So what we're going to do in the next few videos is we're going to break down what can we say about these various shapes. So the circle, the parabola, the ellipse, and the hyperbola. What can we say about them, and a little bit about where they appear, both in nature and in the man-made world around us. So that's our introductory video on conic sections. In the next video, we'll talk a little bit about circles.